हाइब्रिड मोड साउंड तो बड़े से घुमाऊँ ना घुमाऊँ मैं कह रहा अच्छा क्या होमवर्क ले लिया और ले दूसरा नहीं लिया ना
ले लो ले लो ले लो।
निहारी क्या नाम है
हेलो 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 चुप देखिए
देखे हो ओ
परसेंट से भी ज़्यादा मतलब कोई भी एग्जामिनेशन होता है ना वो कभी भी मनुष्य की क्षमता को नाप नहीं सकता। परसेंट से क्या होता है मेरा परसेंटेज आपको क्लास 8 9 के अंदर में 40% भी नहीं होता था 40% भी नहीं होता था कई बार 30% भी नहीं होता था तो ऐसा थोड़ी है कि रातों रात मेरी क्षमता बढ़ गई इसलिए परसेंट को उतना वैल्यू देने का जरूरत नहीं है आप करता है
जाके देखिए
शुरू में 2 महीने करीब उनको जबरदस्ती गया था उसके बाद उन्होंने विद्रोही कर दिया तो मुझे नहीं जाना है नहीं मिला के 2 ही महीने उन्होंने अपनी मगर उनका जो मिशन है उससे पढ़ा है ऑल सब्जेक्ट्स क्लास 5 तक का बोला था पूरा अरिथमेटिक में ज़्यादा किताबें होती नहीं अरिथमेटिक का एक सैचुरेशन है तो उतनी चीज़ें होनी है वो तो हाई स्कूल जहाँ तक भी अरिथमेटिक है सारी अरिथमेटिक में उनको ऐसे बढ़िया मतलब कोरिलेशन काफी कमजोर है सेल्फ मोटिवेशन का मतलब ये होता है कि अगर उसमें मेरा दिल है तब सिर्फ मेरे को कंट्रोल करने वाला है। ये प्रश्न बड़े सब्जेक्टिव होते हैं ऑब्जेक्टिव आंसर नहीं होता है
स्वागत करती हूँ कि आप अपना
बेस्ट है
हाँ बताइए
ऑर्गन फाइट में ओपन एंड से रिफ्लेक्शन कैसे होती है स्प्रिंग में बहुत अच्छे से समझ में आ जाता है लेकिन ऑर्गन फाइट में नहीं समझती
इट्स लाइक रिफ्रैक्शन जैसे रिफ्रैक्शन होता है ना तो आप डेंसर से रेयर जाओ तो भी रिफ्रैक्शन होता है और उल्टा कर दो तो भी रिफ्रैक्शन होता है तो बेसिकली इट इज द डिफरेंस इन प्रेशर अगर साउंड वेव की बात करते हैं अगर पाइप वगैरह की बात करते हैं तो डिफरेंस इन प्रेशर एवरेज प्रेशर जिसको कह रहे हैं एक तो वेव चल रही है प्रेशर के ऊपर, पर वो जो बेस प्रेशर है जिसके प्लस माइनस डेल्टा पी नॉट में वेव चल रही है, प्रेशर कहीं पे कम कॉम्प्रेशन होता है, कहीं रिफ्लेक्शन होता है, साउंड आगे बढ़ता है, सो द प्रेशर इज चेंजिंग। तो वो जो चेंज इन प्रेशर है वो तो अपने जगह है, तो वेव का एम्पलीट्यूड है, बट देन दैट बेस प्रेशर, एवरेज प्रेशर जो है वहाँ पे, जो वेव नहीं रही तब भी जो प्रेशर है, if that pressure is different and there is some boundary, इसके इधर एक प्रेशर है, उसके इधर दूसरा प्रेशर, तो प्रेशर डिफरेंस जहाँ पे होता है ना, वहीं से वो वेव्स रिफ्लेक्ट करते हैं। स्ट्रिंग में भी अगर आप देखो दोनों एंड तो खैर आपको टाई करना ही पड़ता है स्ट्रिंग के लिए।
एग्जांपल देते हैं कि एंड लूज है।
हाँ, लेकिन पहले उसको ऐसे कर लेते हैं कि दो स्ट्रिंग्स मार, एक का मास डेंसिटी ज्यादा, एक का मास डेंसिटी कम, राइट। नाउ इफ यू सेंड ए वेव, तो वेव आराम से चलेगी एक साइड में जैसे आपने सेंड किया है, लेकिन उस जंक्शन के आज वो स्प्लिट Suppose you send a wave, you have a string, and then that is a combination of two strings, one string with one mass density and the other string is other mass density, and then there is a junction out there. Now if you change this, you give a jerk or you continuous jerk, so the wave will propagate. Now at this junction, there will be a reflection and there will be a transmission. Whether you are coming from this side or you are coming from that side. So whenever there is a discontinuity in this medium density, the waves are. So similarly, when you have this pipe, then the inside pressure and outside pressure is different when the wave is propagating. And from that it reflects. Whenever there is a pressure difference, whether it is, so it will reflect.
सर उसका मैकेनिज्म क्या रहता है, मतलब जैसे कि हम लोग यूजुअली क्लास में समझाते हैं कि भाई इफ द स्ट्रिंग इज फिक्स्ड एट बोथ एंड्स, सपोज इट्स फिक्स्ड एट वन एंड and we hold it at the other and we let's say give a pulse, so that pulse will travel and then it will hit the fixed point, at which point there is a force exerted upwards and then equal force is exerted downward, तो उल्टा रिफ्लेक्ट होके वापस आ जाता है। When we have that end that can move, मतलब वो रिंग पे लगाया है, then it can get lifted and we get the antiload. तो ये मैकेनिज्म समझ में आता है, ये ऑर्गन पाइप के केस में नहीं समझ में आता, हवा के केस में नहीं समझ में आता।
Right. So this transverse waves are easy to see in the longitudinal wave, but essentially it is that. Essentially, whenever you do the propagation, how the wave is propagating. So from the two sides you have forces. The tension here, जो pressure है, tension है, जो कुछ भी है. So that pressure is changing here, is different pressure, here is different pressure. So the forces are from the two sides, and that is so adjusted that it moves forward. And when you have this discontinuity, then the forces will act in a different manner. You have same density of air or same pressure, mean pressure of air, right? And then it is supporting your wave propagation. Why? Because consider any layer, you have pressure from this side, you have pressure from that side, and then it moves. Now, at any discontinuity, the rhythm is different. What kind of discontinuity is there? What kind of difference in pressure is there? Mean pressure. So that exerts this extra force, and then part of it is transmitted, part of it is reflected, and so on.
Why do we treat that as a pressure discontinuity? मतलब I understand if we have two different strings, but we have the atmospheric pressure on both sides, right? And in fact, then we further go on to say that actually the antinode doesn't form exactly at the end. There is an end correction, तो थोड़ा सा वो add करते हैं हम लोग.
Yeah, it will be. It will be because it's not really that way. It is discontinuous. P1 here, P2 here, rho 1 here, rho 2 here. There is a variation. Going from rho 1 to rho 2, there is a variation. it has to fall, but it has to change, but it will take some distance to go for this mean value to that mean value, so it will spread out there.
What she's saying, I guess कि बाहर भी एटमॉस्फेरिक प्रेशर है, अंदर भी एक वेरिएशन, अंदर ज़्यादा या कम कैसे?
बन
Is it
जाता
so?
बन जाता होगा ना वो रिफ्लेक्शन वगैरह हो करके।
Right.
Sir, when we do minimum deviation,
Minimum deviation
prism, we've seen experimentally, we plot the graph, we see everything. But why does it happen that light retraces the path? मतलब देखते हैं ना एक मिनिमम पोजीशन पे आके वापस जाता है, तो वापस क्यों जाता है? Spectrum comes to the minimum and then increases. पर जाता क्यों?
बात तो सही है वो
What is it? कुछ तो मतलब what is it?
why there is a minimum deviation?
हाँ, why is it that the light comes till there for prism and then goes back?
Same story. Why there is a minimum deviation?
हाँ.
Why the deviation is minimum? Good. Huh? While thinking, so let us suppose when angle of incidence increases, deviation increases. There's no coming back and now. So this is our angle of incidence, and this is finally the delta. That means it bends like that. Now if I increase this I,
गलत है ना
Sir,
वो एंगल
angle of incidence तो normal से बनता है ना?
हाँ
अच्छा,
ऊपर.
that's it. कोई बात that is true. Fine. Now I am looking for this angle and this angle, I1 and I2. Okay, fine. I2. Is there a relation? If I1 increases, what happens to I2?
I1 increases, I2 will go up.
नहीं नहीं
नीचे
R1, R2, R1 plus R2 is equal to A.
हाँ
So if R1 increases, R2,
it should decrease.
let us say, here it is R1, normal से, it is normal, ये, this is R1, correct?
Yes, sir.
And that is R2. R1 plus R2 is, so if R1 increases, R2,
Decreases.
so if I1 increases, I2,
Decreases.
right? Okay. So if I look at this picture, and I have a rule, as I increases, this delta also increases. Suppose this is the rule. Now if you reverse, if you send the light from this side, and look at it this side, the same geometry, so delta remains the same, this way or that way. So the rule which said that if I1 increases, delta increases, or if I see from the other side reverting the arrows, the rule will become, if I decreases, then delta increases. The delta is same. By inverting the arrows, just inverting the arrows, the deviation is the same. So initially I said that I1 increases, say I1 increases, delta increases. But for the same increase in delta, if I come from here, my angle of incidence is decreasing. If I1 is increasing, I2 is decreasing. Now this I2 is my angle of incidence. Delta remains the same. Inverting the arrows in the prism picture, how much it has bent is the same. आप इधर से भी चलोगे, पर ये चल रही है,
Yes, sir.
ये चल रही है, ऐसे निकल रही है, ये चल रही है, ऐसे निकल रही है.
Yes, sir.
Delta is the same.
Yes.
But I1 and I2, they have reverse relation. If I1 increases, I2 decreases. If I1 decreases, I2 increases. So this rule, if I see from that side, I get the opposite rule. The rule was, if the angle of incidence increases, delta increases. But if this angle of incidence increases, that I2 decreases. And if I say that that is the angle of incidence and it is coming this side, the rule will become reverse. So this cannot be the rule. Whenever I increases, then delta increases, this cannot be the rule. Huh? For some other person, it is the reverse. No, I am decreasing I, and then I am seeing the delta is increasing.
Yes.
So it will keep continuously increasing, cannot be the rule. It keeps on decreasing continuously. I increases, delta decreases. This cannot be the rule. So there has to be a minimum deviation. Alright? And at that point, so it increases, then decreases. And from this side also you come, the same rule should apply. It should not change if you just revert the arrows. If there's no preference, you send light from this side or send it from that side. The rule should be same. So there should be a minimum deviation. Monotonic increase is not allowed. Good. We never thought about it. Yeah, we never thought about it. We took it granted that there is a minimum deviation, and then we found that okay, mathematically or from symmetry, when this delta will be minimum, blah blah blah.
Sir, can you tell about electrostatic shielding?
Yeah.
Shield.
Electrostatic shielding. So are you talking of if there is a metallic surface, conducting surface, not necessarily spherical? Let me understand what do you mean by electrostatics? Shielding. So if I have a conductor and I have a charge out here outside, then for these inner points the electric field of this charge is not experienced. Is that the case? Alright. So let us say this is a solid conductor. there is no space inside. It's a solid conductor. So, and there is the outside charge Q. What happens inside? What happens inside? Will there be an electric field here? This is a solid conductor.
No.
No. Right? No.
That's why, sir. Why? That is no. Electric field inside the conductor is that is even if it is a solid conductor, the charges are accumulated outside.
Why? Why? Okay. Okay. Fine. Good. What is the difference between being a conductor and being an insulator?
Free charges.
Extra charge, free charge particles.
Bounded charge.
Free charge and bound.
Free charge and bounded
Bounded charge.
It is, if it is conductor, that means there are many electrons. There are many electrons who have forgotten their permanent address.
Yes.
I belong to this atom. Right? If you just consider one atom in isolation, there are so many electrons depending on what element it is. If it is iron, let us say there are 26 electrons. If it is carbon, there are 6 electrons. Silicon, 14. So there are so many electrons, and each electron knows that I belong to this atom. In a gas, the atoms are moving this side, that side, helium gas, let us say. But then every electron knows I correspond to this helium atom. I correspond to this helium. That's the permanent address. Now in insulators, by and large, this information is retained. For any electron, you know that this electron belongs to this atom and that electron belongs to that atom. Then it is insulator. But in conductor, there are many electrons. Each atom, say, donates one electron for moving here, going here, to there, there to there, there to there, there to there. This atom to that atom, that atom to that atom, that atom to that atom, hopping. So now they don't have any permanent address. And they are so mobile that if there is an external electric field, they will start moving. Because they are not tightly bonded with the remaining atom or ions. Once the electron has gone out, the atom has become ion. So conductor consists of large many ions which are there at their respective places, maybe vibrating little bit, but and then there are huge numbers, because the number of atoms is huge in any small piece of the matter. It's in 10 to the power 23, 24, 22. And if each atom gives one electron, you can imagine how many electrons are there, which are free. We call them free electrons. So, if I have a conductor and there is a charge, this charge does produce an electric field here. Nothing doing. The job of a charge is to produce an electric field, no matter who else is there. So this charge produces an electric field. But if the free electrons are there, this electric field will exert force on the free electrons opposite to itself and will make it move. They can move. Free electrons can move. This solid, this dense solid is not a big hurdle for them. They can move in the solid. They will jump from this atom to that atom, that atom to that atom, and can move. So if you apply this electric field, or this charge Q creates this electric field, the electrons which are here, they will start moving in the opposite direction. And where will they go? Because here also there is an electric field, here also there is an electric field. So ultimately they will reach surface. And that is how you have some charges, some positive charges appear here, and negative charges appear here, and you say that charges are induced. If I charge something and put it here, this charge produces a field, and if there's a metal, you bring this charge close to the metal, then you say that if this is plus, negative charges here, positive charges here. This will happen in the insulator also. But in insulator, this electron cannot move to that electron. Only the electrons which are close to the surface and atoms, those electrons will slightly shifted in the atom. They are still bound in that atomic volume. So they know their permanent address. But then, okay, they come to the window to see what is happening outside. Okay. So in an insulator, if this is the case with insulator, this is insulator, and then the electric field because of this is like this. This electron will move in this direction, right? But it will not leave the atom. It will only slightly shift. This electron cloud is only slightly shifted. So this has no role up to here. But then these electrons, these atoms, here also the cloud is slightly shifted, and therefore the electrons will come to okay, opposite. This, let's say plus Q, the electric field is this way, so the shifting is towards left. Now this electron cloud here, when these electrons are slightly shifted, you get some slight charges here. But in conductor, same mechanism, but now electrons are not bound to the atom anyway, they will be random motion. So this applied electric field will give the surface charge. This process will continue. More and more electrons will be going this side, that side, depending on the direction of the field, till the electric field at all points inside the conductor becomes zero. Because these extra electrons here and extra positive charge appearing here will create an electric field in this direction. This is the direction in which this will create a field. Okay. So this electric field which was produced by Q will be weakened. You will have an opposite field. So it will be reduced. The resultant field will be reduced. Right? Before the shifting starts, there was an electric field. When you put, suppose at some time you put Q charge here, so there is a field. But that field will create this charge separation. So on the surface, on one side you get negative charge, other side you get positive charge, and this accumulated charge on the surface starts creating its own field, and that field is opposite to the field of the external charge Q. And till there is even a small electric field left, this process will be continued. So it will stop only when things are settled, only when the electric field inside the conductor becomes zero, so that the free electrons are once again free and they are not misguided by this external field of that Q. So they are now again happily wandering inside. Okay. So this is the mechanism of electric field inside the conductor to become zero. That means the charges on the surface now you have two kinds of charge distributions. So this is one charge external, and then these are the extra charges which are appearing on the surface. And inside everywhere E is zero. E is zero. E is zero. Okay? So the field at any point, due to this Q and due to this charge distribution, the resultant of that is zero. The resultant of that is zero. The resultant of that is zero. Now, suppose very meticulously we remove all the material from inside, leaving a small thin shell there. So it becomes a hollow conductor. There are no charges here. No charges means you do have free electrons, but then the positive ions are all there. There is no charge density there inside this metal. So if I remove all this material, what is left? This charge distribution and this charge distribution. And they produce electric field 0 at all the points. Okay. So even if you don't have the material there, the resultant electric field is still there. It's not that the field of Q is not reaching the inside, but you have an extra charge distribution on the surface which nullifies that. So even if it is a hollow conductor, there is no material, and my argument that if there were a field, there will be a motion of electrons and it will shift and this and that will not work here because there are nothing, there is no material, there is no electron. That argument will not work. Some other argument I have to search. But simple thing, that this charge distribution plus this extra charge is creating 0 field, and when the material was there, it was doing nothing. When the inside material was there, that material initially it gave me that charge distribution on the surface, but once the charge distribution was established, after that there is no role of this material which is just sitting there. Remove it. You will still have E equal to 0 here, everywhere. So the effect of external charge is nullified by producing this army. वो फ्रंट पे सब भेज दिया सैनिक वैनिक यार बाहर से कुछ आ रहा है लो, तो सीमा के ऊपर बहुत हलचल हुई, उसके असर शांति है, अंदर भी शांति है, बाहर भी शांति है. So that's the mechanism of, if this is called electrostatic screening, then this is the mechanism.
They give an example, sir, Faraday cage.
So this is okay. So in Faraday, that is an experimental demonstration of the fact that even if you don't have a solid boundary, but boundary of the gaze type, so you have gaps so that you can see what is happening inside. So basically it behaves as a this metallic shield.
So by touching the bars, we can't get any shock. If we touch the bars inside, if we are standing inside the cage, there is a electric discharge over the cage. Suppose if we touch the bars, can we get shocked or not?
I've never tried.
So there are experiments on YouTube no, about this.
No, we have one example. Again, one more example. During lightning, it is safer to sit
In the
inside
car.
a bus or
Correct.
car
Correct.
because there is a electric field inside the car is 0.
Correct.
Suppose if we touch the window bars or any other iron material inside, can we get shocked or not?
I believe you should.
Then you are becoming the part. No? It will move.
Lightning or
In fact,
Because you're giving up.
that's another story.
during rain and thunderstorms.
Instrument can be
Yes,
there.
it is advised. So how?
You
This
become,
is
by touching
the metal.
my thought processes,
Hmm.
by teaching, you become part of that metallic system. So everything has to be at the same potential. Like that surface is equipotential, it has charge, but then the potential is same. So I have to also go at that potential if I touch it. If my body is a conductor. So in that case, from 0 from no charge here, I will get charge. So I think it's not safe to touch.
But to sit is to save, na?
Electric pole is on the storm and on the pole falls on the car. And they just told that as long as you are in the car, it's safe. But as soon as you will put your stem over here, the potential difference will electrocute. So better is that you just take a jump like this. Even when you move, don't move like this away from the check your both feet on the same surface. So that every time you on your body.
Yes,
Same
yes,
potential
yes.
surface, na?
I have heard about it.
So the
Very correct.
important lesson of this discussion is that the surface charge on the metallic surface and the external charge, they will always produce a zero field at all points inside that metallic component. And if it is not a conductor, if it is an insulator, this effect will still be there, but it will not exactly cancel the external field. The field can exist. And how much is the field? That is defined by the dielectric constant. It is reduced, but doesn't become zero. In metallic conductor, it reduces and it becomes zero. Because of the free availability of it. In insulators or in dielectrics, the electron cloud can only slightly shift. Only less charge can come on the surface, and there is a net electric field inside the dielectric.
So इस केस में इसको पोलराइजेशन कह सकते हैं जब इलेक्ट्रॉन शिफ्ट होता है.
Yes, that is polarization. That is indeed polarization.
जो डायलेक्ट्रिक्स में भी बता.
The dielectrics, yeah. Polarization is the same thing. When this cloud shifts, the positive ion doesn't shift. So if you think of this cloud as an equivalent point charge of that polarity, you have a dipole. The positive ions, positive charges has a center, negative charge has a center, and now it has shifted. So a dipole moment has been created. So how much is there of dipole moment per unit volume? That is called polarization. And you can also have dipole moment in your atoms by design. It's not due to the electric field. That's one story. Other story, hide this water molecule, for example, water molecule. There is a dipole moment, huge dipole moment at that scale. At atomic scales or molecular scales, water molecule has a very big dipole moment built in. You don't need it. But then there are like your magnetic moments, these electric dipole moments, they are all randomly oriented. So there is no charge appearing anywhere. Now when you apply an electric field, there is an orientation. In the direction of electric field, that randomization will be reduced. And then you will find that, okay, yes, dipole moment has appeared. In a volume, every molecule has a dipole moment. But then if you take a volume, say 1 millimeter cube, there are so many of them, and all randomly oriented. So there is no dipole moment of this volume. Although every molecule has dipole moment. But once you apply a field and a slight orientation, then this will acquire a dipole moment. So that dipole moment per unit volume is polarization.
Sir, how can we summarize the four Maxwell equations? How can sometimes I do find it difficult because पहले इलेक्ट्रिसिटी पढ़ लिया तो वो समझ में आ गया, फिर वो मैग्नेटिक फील्ड पढ़ लिया, फिर EM वेव्स तक गए, तो सर इन दैट टाइम मतलब हाउ टू कोरिलेट देम, सर हाउ कैन वी समराइज फोर इक्वेशंस?
Do you need that?
सर some explanation, sir.
Do you need that?
हाँ.
Displacement Pinky ma'am, they are only fundamental. Displacement करेंगे आगे सब कुछ.
क्या दिया है मैंने पढ़ा नहीं है NCERT.
Sir, Maxwell equations are there.
4 equation.
Maxwell equations. Explanations.
How
How to correlate.
do we define that law? कैसे लिखते हैं equations कैसे लिखते हैं?
Integral E dot ds is equals to q by epsilon naught.
नहीं any Gauss law for example.
Then the E equal to rho by epsilon.
Integral form. Yeah. Okay, so next.
Integral B dot ds is
So you have, Acha, what does this tell? This is equal to
q by epsilon naught.
Q inside by epsilon. What does it tell? Finally, it relates the electric field and the charges. On the right hand side, you have charge distribution, charges. Right? Inside you are looking, but whatever, charge distribution. Right hand side is charge distribution and left hand side is electric field. So it essentially tells that charges create electric field. And how much charge will be created, how much field will be created by how much charge, that will be given by this equation. So this tells that the essence of this basically is that charges, electric charges produce electric field. Okay? You have charges, you have point charges, you have point source of electric field. You have source of electric field like a point from where the charge, the electric field is generated. Okay, na? Then you have B dot ds equal to 0. What does it tell?
That
There
magnetic
are
field can
no point sources of B field. This says that yes, you have point sources. You have point sources which produce electric field. Charge Q. What is that charge Q? You have a point. You have a localized charge, and these are point sources of electric field. This. Okay. Correct. Correct.
सर एनसीईआरटी में एक स्टेटमेंट लिखी है गॉस लॉ से रिलेटेड ही 3 स्टेटमेंट्स लिखी है मैं थर्ड स्टेटमेंट पढ़ रही हूँ इन द सिचुएशन when the surface is so chosen that there are some charges inside and some outside the electric field bracket में लिखा है whose flux appears on the left side of the equation is due to all the charges both inside and outside S.
Correct.
And the term Q on the right side of the Gauss law, however, represents only the total charge inside X.
Correct.
तो ये वही सिचुएशन थी सर जो सर अभी आपने बताई थी कि चार्ज बाहर भी थे और चार्जेस बट वो कंडक्टर के केस में था सर ये वाली स्टेटमेंट कि इलेक्ट्रिक फील्ड जो लेफ्ट हैंड साइड पे है वो बाहर और अंदर दोनों के चार्जेस की वजह से
Correct. See, Gauss's law in this form handles a closed surface. It's not point by point relation. It is what happens in totality over the surface. E dot ds here, E dot ds here, E dot ds here, E dot ds here, E dot ds here. You sum all those E dot ds. You get a quantity which is the left hand side. Integration of E dot ds. So it is not giving you actually, initially it is not giving you E, immediately. You have, there are some symmetries, etc., you find, okay, this is the electric field due to this charge. Now, if you have a point here, this point will create an electric field here, and this will also create an electric field here. It will create an electric field here, and also it will create an electric field here. It will create an electric field here, and it will also create an electric field here. It will create an electric field here, and it this way, and then it will also create an electric field here. Right? Now, if you look at this E dot ds from here, E dot ds, E dot ds, E dot ds. So there is an electric field. It's not zero. And there are no induced charges. So that way it is different from what I stated earlier, electrostatic shielding. There are no charges to cancel this field. There is a field. Indeed, there is a field. Because this is the only charge I am considering. This is the only charge in the space. So there is an electric field. But if you consider this E dot ds, the normal is this way. Here the normal is this way. So when you calculate that E dot ds, that will be negative here, obtuse angle. E dot ds will be positive here, acute angle. So that E dot ds, E dot ds, E dot ds. Individually, every E dot ds is there, but some of them are positive, some of them are negative. So that left hand side does not depend on the outside charges. You have to only look for the inside charges. But every point you do have a field because of this outside charge. That is it. Now, coming back to Maxwell's equations. So we have done two of them. Half the electrodynamics is done. Yeah. I mean, are you asking historically, did Maxwell write it in this form? Is it your question?
Kind of, मतलब जो हमने graduation में थी, that was del dot D.
That was in terms of current density.
मुझे याद है, वो मुझे याद है, बहुत कम चीजें याद रहती है मुझे, but this is something which I remember.
जीरो
ये क्या है?
ये तो डाइवर्जेंस के लिए है.
वगैरह. See, historically, Maxwell, when wrote these Maxwell's so-called Maxwell's equations, there were not 4 in number. The number was very large. I don't remember some 12 equations or 15 equations. There's a huge number of equations. But essence was that summarized all the information which is there, which was there for electricity and magnetism. And then looking at the experimental data, Maxwell himself had to add that so-called this displacement current type term there. So that was his own contribution. But then the big contribution was that all the electricity magnetism data was summarized in these form. And it was not in this form, neither in this form nor in that form. Maxwell's equation, which Maxwell wrote, was integral in terms of the integrals, not in terms of these differentiations. These are differentiations essentially. It was in terms of this, but not in the form that we studied today. Interesting history. I had happened to get this original paper. I read many years ago. And after that, people, other scientists looked into it, and then they found that there is an interdependence. Okay, so when that interdependence was removed by modifying his equations, so that I get an independent set of equations, then at the end they converge with these 4 equations that we studied today. Okay, now the third equation. Third equation is this. What is this? क्या होता है?
Integral E dot dl. Integral E dot dl is equals to minus d phi by dt.
What does this say?
So integral E dot dl. Yeah,
E dot dl.
Yes.
E dot dl.
Change in magnetic flux.
Correct.
Flux can also be the source of electricity.
Correct. So left hand side you have this E dot dl, right? Right.
Minus
So
d.
here is the electric field, but that electric field is not related to any charge, but related to right. So
Magnetic
and
field.
it is B into area, So essentially, it is a B.
That is changing.
Changing magnetic field is the source of electric field. Okay? So that equation, third equation, tells that electric field can also be created by changing magnetic field. Point sources are not needed. Fine? And then you have fourth equation. B dot dl है क्या?
हाँ सर.
Integration
Integral
B
B
dot
dot dl is equals to mu naught I plus mu naught epsilon naught d phi by dt.
d phi e.
Yes, d phi e by dt. Yes.
Okay. Now what does this tell? It tells that magnetic field is produced by current. That's number one. And magnetic field is also produced by changing electric field. That's it. That's the summarization of 4 Maxwell's equation. So the masses, apart from the quantitative treatment and the values, the masses of Maxwell's equation is number one. Electric field is generated by point sources. And if you combine with that fourth one, the third one, also by changing magnetic field. Magnetic field is not created by point sources, second equation, and is created by currents and changing electric field.
So,
That's the
so
story.
please repeat second line, sir.
Sir, we cannot measure displacement current.
What?
अरे मेजर करने को क्या नहीं मेजर कर सकते हम जो कहो तो वो मेजर करते हैं टेक्नोलॉजिकली बहुत एडवांस्ड है हम हाँ
Sir, second point. Sir, second point. Please repeat.
so E sources of E sources of electric field. This equation tells that Q is a source of electric field, point source, point like source. And this equation here, third equation, this also tells that okay, there will be an electric field if magnetic field changes. So about electric field, this first and third equation, they are about electric fields, and essential message is electric field is created by point sources of charge and also by changing magnetic field. Now the second and fourth. This tells that magnetic field, on magnetic field there are no point sources of charges. This is the message from the second one. And third one tells that how it is created. It is either created by a current or by changing electric field. d phi E, flux of electric field, and dBt. If that changes, that flux changes, it becomes a source of magnetic field. Just like here, if your magnetic field changes, that becomes a source for electric field. So if the electric field changes, that becomes the source of magnetic field. And this additional. If you have a current, electrons moving, charges move. So moving charges can create magnetic field. You don't have point sources.
Gives out magnetic.
You don't have point sources. The charge does not create magnetic field.
Or moving.
Or there is no analog of a charge. Electric charge, this is magnetic charge. There are no point sources. But the same electrons, same charge, which was a source of electric field, once they start moving, then together with creating electric field, they also create magnetic field. So all your Bat-Savart law and the circuitial Ampere's law, all those things will come from there. The moving charges, moving electrical charges, produce magnetic field. Of course, they produce electric field. If there are charges, they will produce their own electric field. But they also, on top of that, they also produce magnetic field.
Only accelerated charges.
No.
So even if they are even if the charge is moving with the constant velocity,
They produce
electric field, they produce magnetic field.
magnetic.
But for EM waves, we need
EM waves is a difference. EM waves is this is the essence of these 4 magnetic Maxwell's equations. And then when you work more on it, Then it says that electric field and magnetic field can also be combined in a self-sustaining mode. You have an oscillating electric field which produces magnetic field, and then you have oscillating magnetic field which produces electric field. So there can be a self-sufficient ecosystem. No need of any external sources.
Yes.
So once it started, this EM wave, once it started, there's no role of how it was for the first time generated. De-link, completely de-link. You remove that, whatever had produced your electromagnetic wave, remove that. We don't need that. Now, the changing electric field is creating magnetic field, and then that magnetic field is also changing, and that creates electric field.
Yes.
So we can have this kind of variation of electric and magnetic field, which can self-sustain each other.
Self-sustain, yes.
So that comes from these equations.
निहारिका मैम अच्छा सॉलिड है ना कंसेप्ट एकदम बढ़िया
In principle, yes. In principle, yes. If d phi dt is constant. नहीं बना सकते हैं कि नहीं बना सकते? Principle. So one is principle, one is technological competence. Okay? So physics-wise, why not? Your EMF is minus d phi dt. Phi should change linearly with time. Magnetic field at each point, if it changes linearly with time, अगर आप ऐसा कर सकते हैं कि dt आपके कांस्टेंट रहे, तो आपको फिर वो कांस्टेंट EMF मिलता रहेगा. Now it's a question of technological thing. You कैसे इंश्योर करोगे? There is a magnetic field and it is increasing. It keeps on increasing linearly with time. So if you can make your coils and this and that and manage the current outside, blah blah blah, that's a technological aspect. Can you create a situation so that something is moving, something has to move, DDT लाना है आपको, हमें DDT लाना है आपको, so that flux B dot dA integration on that area, that should change linearly with time. So that's a different aspect. Can we do that? That is a different aspect. But yes, in principle, mathematics or physics says yes. The answer is yes.
Sir, one more point.
हाँ.
और ये d phi e by dt से बड़ी magnetic field है. d phi e by dt वाली करंट भी देती है, एडी करंट देती है, हीट भी कर देती है. क्या म्यू नॉट आई वाली भी हीट करती है? मतलब अगर उससे मैग्नेटिक फील्ड बनती है. मतलब ये दोनों एग्जैक्टली सेम टू सेम टाइप की फील्ड्स देंगी.
Okay. नहीं वो उल्टा उसका पूछ रहे हैं. इलेक्ट्रिक फील्ड के फ्लक्स से जो मैग्नेटिक फील्ड पैदा हुआ है और जो करंट से जो मैग्नेटिक फील्ड पैदा हुआ है, उनका क्या रिश्ता है? उधर वाला तो मुझे ज़्यादा फेमिलियर है.
आप उधर वाला भी बता दीजिए.
क्लोज लूप का कंसेप्ट क्या है कि मैग्नेटिक फील्ड डू नॉट फॉर्म क्लोज लूप.
One is E dot ds is equal to Q over epsilon.
It comes from which
And other is
definition? First,
this is surface integration, and then this is a line integration.
close integral is zero.
Is equal to d phi b by. So electric field can come from changing magnetic field. Electric field can also come from point charges. Now these two electric fields are identical in behavior with respect to F is equal to QE. Whether it is this electric field or that electric field, force on a charged particle Q will be F is equal to QE. So that way the two fields are having same behavior. The force is in the same direction, the same magnitude, the same equation, F equal to QE operates for this field as well as for that. But then there's another story that for this kind of field created by charges, if you do this line integral over a closed path, for this field it will be zero. But in this field it is not zero, as you can see right here. And we define our potential corresponding to electric field by this dV is equal to minus E dot dl. Correct? So if I start from here and come back here, this is not zero. This is not zero. This is here minus d phi dt, d phi b dt. That means you come back, if you define potential corresponding to this kind of field, dV is minus E dot dl, you do one round, the potential is increased at the same point by say 2 volts. You go second round, at the same point the potential is now 4 volt, potential is 6 volt, 8 volts. So you cannot define a potential. At one point there is not one potential. It depends on how you created the loop, what is the path and how. So you cannot define a potential with the definition dV equal to minus E dot dl for the electric field created by changing magnetic field. But if it is because of the charges, no problem. You do this integration, it will come out to be zero. So potential has a unique value there. The change in potential E dot dl minus E dot dl minus change of potential, if you sum on the closed loop, it will be zero, because if at this point it is 12 volt, it is 12 volt, that's it. So it's a useful quantity. Every point you assign a potential, it's a useful quantity. But this has no meaning. At the same point, depending on what kind of calculations I am doing, sometimes I am getting 2 volts, sometimes I am getting 5 volts, sometimes I am getting 7 volts. So we say that a potential cannot be defined corresponding to the electric field created by changing magnetic field. That means, in other words, we have a technical term for this long sentence, that electric field due to changing magnetic field is non-conservative. Whereas the electric field corresponding to charges, that electric field is a conservative electric field. Right? So this is the difference. Mathematically, same story. Magnetic field is always non-conservative, because magnetic fields are not, there are no point sources. वहीं से तो वो वाला part है ही नहीं. Even the one which is created by I, capital I, current, falls in this category. उसका भी अगर आप करोगे तो वो आपको मिलने वाला नहीं. तो मैग्नेटिक पोटेंशियल्स कभी नहीं डिफाइन करते.
मैग्नेटिक फील्ड ड्यू टू
मैग्नेटिक पोटेंशियल्स कभी भी डिफाइन नहीं करते.
ड्यू टू इलेक्ट्रिक फील्ड.
उनका ले लीजिए.
मैग्नेटिक फील्ड ऐसा जस्ट नॉन कंजर्वेटिव. तो जो चेंजिंग मैग्नेटिक फील्ड से इलेक्ट्रिक फील्ड बनती है ना, वो नॉन कंजर्वेटिव होती है. बट चेंजिंग मैग्नेटिक फील्ड, वो जो डी फाई बाई इंड्यूस्ड इलेक्ट्रिक फील्ड जो होता है,
अच्छा,
वो नॉन कंजर्वेटिव होता है.
इंड्यूस्ड
इलेक्ट्रिक फील्ड इंड्यूस्ड चार्जेस की वजह से.
थर्ड इक्वेशन.
हाँ,
हाँ, वो क्या होती है?
कंजर्वेटिव.
अच्छा, दिस फील्ड इज,
सच इज नॉन कंजर्वेटिव.
अच्छा, वो खुद नॉन कंजर्वेटिव होता तो नॉन कंजर्वेटिव बनाती है. ओके.
बट इलेक्ट्रिक फील्ड ड्यू टू द चार्जेस
This man is, with respect to this man, the lift is moving as well as the charge is moving. His compass will get deflected, and as well as the charge will also get some. There will be some electrostatic force too. Is it so?
Yeah, why not? There are two different people having two different dishes. So something is happening there, something is happening there, something else is happening here. What is the problem?
Means net force here will be different and it will be different.
Okay, there is a conclusion. Then you are asking that.
But the changing electric field produces the
Changing magnetic
See,
field
this
produces
charge-
electric field.
but changing electric field produces a
Compass is
magnetic
the
field
thing,
also, no?
right? Is
And
there
that
a
magnetic field is
For this case, there is no magnetic field. And if you see this, I reframe your question. Forget this. The person is there, but he is looking at the lift. The person is looking at the lift. So this person's dilemma is, this person says that, okay, there is no deflection in my compass, although to hold this capital Q, I have to exert forces. So this Q is creating an electric field, creating a force here, and to keep it in equilibrium, I have to hold it. Otherwise, it will be affected by that. But the compass is no problem. Compass, even if I am putting on the table, not holding it, it doesn't deflect. Good. Now this guy says that this charge is moving, so it is creating a magnetic field. There is a compass out there. So this magnetic field which this charge is creating must exert a torque and it should deflect. होना चाहिए. And since it is moving with a uniform velocity, this is also a good inertial frame. So the rules which are valid for this ground frame should also be valid for the lift frame. I mean, both are inertial frames. So that's the dilemma. Whether the compass deflects or not deflect. As a third person doing only this problem solving on paper, we are in a fix that if unless we go to the left with a compass and a charge, whether it deflects or not, if we want to get that answer from our equations, then if this person applies those same equations, it tells that yes, this Q is going up, so it is creating a magnetic field here, and therefore this compass will deflect. And this person says that no, the charge is not moving, so it doesn't create any magnetic field, and therefore the compass will not deflect. So two predictions, opposite predictions. So if I am not in the lift, I have not seen what happens to the compass, then we'll keep quarreling. But if you see what happens there, one person will be very happy, other person will be thrown out. गलत बोल दिया था तुमने, जबकि क्या गलती थी? दोनों में से जो भी हो जाए, if it deflects, then this lift person is out of the job. It doesn't, then this person is out of the job. That's the dilemma. Both are applying, both are very honest people. Both are applying the physics laws with utmost accuracy, no slips. The problem was read very carefully. That is the dilemma. The answer is the electric field and magnetic field, due to a charge distribution, as seen one frame and as seen in the other frame, they are not equal.
Okay.
I have certain charges here, okay, which some of them are moving, some of them are not. Both current distribution and charge distribution thing is there. Now, because of this, there is an electric field and there is a magnetic field. If I am looking at those electric and magnetic field, I am not looking at the charge, I am looking at those electric and magnetic field from one frame. I get, okay, electric field here is even, magnetic field is even. But if I look at the same electric magnetic field from other frame, I change my frame. I don't know what was the charge distribution, I am not tampering with it. I am only looking at the electric field and magnetic field at this point, center of the left. So different people in different inertial frames will say that the electric fields are different and also magnetic fields are different. And there are relations, there are equations how to go from this electric field, magnetic field to those electric field and magnetic field. Okay? Now the force is given by QE plus QV cross P. So not going into relativistic speeds, very high 10 to the power 8 meter per second, etc. Everything is in meter per second or centimeter per second. From different frames, E is different. From different frames, B is different.
Yes.
From different frames, the velocity of the charge is different.
Yes.
But when combined everything, the force will come out to be the same. Okay? The force comes out to be the same. So in this case, in this particular case, there is no magnetic field, so there is no magnetic force. But there is an electric force.
Yes. Yes.
There is an electric force, electric field.
Hmm.
So if you take this charge, let us say this charge. So this electric field creates a force and that's the resultant force. This person will say that charges are moving, this charge is moving, this charge is moving. But this moving charge creates a field, magnetic field that acts on it. Q, V, cross. And this force and that force combined will remain the same. Will remain the same. So this is the relation between these. So electric field and magnetic field are not absolute quantities. The same field, which is, there was no magnetic field in one frame, and in the from the other frame the magnetic field was there. That's the story?
Yes, yes.
That's the story. So it's not that the magnetic field is magnetic field, see it from anywhere. So there was no magnetic field and magnetic field appeared. I changed my frame, I did not disturb anything else. I changed my frame and the magnetic field appears. The electric field was not there, in some cases the electric field appears. Or EV both are there, the values are changed. So it's something like this. Let me give you an analogy. I have a vector and I choose this x-axis. Okay? I choose this x-axis and this y-axis. Suppose this is a vector. I choose this as the x-axis, this is the y-axis. Fine? And look at the components. The component of this here is E cos theta and here E sin theta. And they are all, their actions are independent, the force in this direction will not disturb velocity on that direction, blah 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 blah. Now I change my xy axis. I am choosing another x-axis which is somewhat tilted and correspondingly y-axis also tilted. The x component of electric field has changed.
Yes. Yes.
And y component of electric field has changed.
Yes.
Vector is the same.
Vector is the same.
Vector is the same. The two components depend on which xy axis I am choosing. Right? Because that decides theta, cos theta, sin theta. I might tilt my frame, rotate my frame, so that theta is reduced or increased.
Yeah.
Change. But my vector did not change. So it's the same electromagnetic field. Think the electric field and magnetic field as, it's an analogy. Electric and magnetic field as components of this electric field, electromagnetic field, for this particular frame, ground frame. If you go to another frame, lift frame, You have changed the components, but the electromagnetic field is the same.
Components.
Component change.
You have changed electric field, going from one frame to the other frame, moving with respect to this one with some velocity v. Okay, so since you have changed the frame, good, electric field has changed,
Yes.
magnetic field has changed, but the electromagnetic field is the same. The same field is seen from this frame, the same field is seen from the other frame. The same vector is seen from these axes,
Yes.
and the same vector is seen from some other axis, जिसको हमने rotate कर दिया. The components are different. So electric field is different and magnetic field is different. No problem.
The net force will be same.
Net force will remain the same.
Same.
Net force remain the
Same.
will remain the same if you have a physical system. Both inertial frames have.
Very,
Okay?
very nice. बहुत अच्छा है.
Sir, one last question.
How do you know it is last?
How to explain hydrostatic paradox?
What is that?
Pascal's law. Pressure is same. Whatever is the shape of the container.
Oh,
Forces
Height.
how to
हाँ कुछ ऐसा ऐसा बनाते हैं ना लोग कुछ
मैम की टेबल पे
कनेक्शन भी
मैम
करते
की
हैं।
टेबल पे मैम की टेबल पे
क्या?
नहीं अलग ही बनाते
तमन्ना
हैं।
मैम मैम की टेबल पे
नहीं करने
कुछ रखा है
लगातार एक दूसरे से वाइस सेम वाइस से बंद करो।
देखो आपका है तो
बना दी
कनेक्ट नहीं भी करो तो भी कोई बात नहीं है, fill it at the same level.
how do you calculate weight of
Okay? ठीक है ना? पहले इसी को कर ले. So what is the paradox? We say that the pressure here is same as the pressure here and it's same as the pressure here. So what is the paradox? क्या problem है इसमें?
the amount of fluid is different.
Amount of fluid is different. Right? Okay. Okay. So this area is A. This area is अच्छा the base you take the same thing. Is it that? The base is taken as the same. I am not very familiar with this hydrostatic paradox. So this area is same. This area is A and this area is A. And the pressure we say that it's same. So the force here, this force here will be P times A. Right? The force by the bottom on the water. The force by this bottom on the water will be here, F will be equal to P times A. Here also, if the pressure is same as we say and area is same, then force is P times A here also and force is P times area. So if I am taking the same area and I am taking the same pressure at the same level, then this force is same.
Yes.
But the weight of this is less. This is W1. Weight of this liquid is W1. Weight of this liquid is W2. And weight of this liquid is W3. And W1 is smaller. And W2 is larger. And W3 is even larger. Because of the shape of the vessel. You have less water in this. You have more water in this. And you have even more water in this. So the weight is different and the upward force is the same. How can it balance? Is that the paradox?
Yeah, that's the paradox.
That's the paradox. So,
Weight.
ये पैराडॉक्स है मुझे तो लगता है सभी जो पॉइंट सेम हाइट पर है वो उन सबके लिए प्रेशर कांस्टेंट होगा
Good.
यही पैराडॉक्स है
नहीं ये पैराडॉक्स यहाँ नहीं है. पैराडॉक्स ये है कि I agree with it. I agree with it. मतलब कैसे निकालते हो तो जानते हैं हम कैसा भी शेप वेप रहे. If I have 2 points, one here and one here, here pressure is P1, here is pressure is P2. So you can think of a thin vertical column of cylinder, and then the force this side is P1A, and this side it is P2A, and the weight is there. This weight is there, W, which will be area into height. Area into height is the volume times rho and times G, and from there I know that okay, whatever that P2 minus P1 is rho GH. So if you keep the H same, then the pressure difference is same. So open to atmosphere, so here the pressure is P0, atmospheric pressure. Here also P0, atmospheric pressure. Here also P0, atmospheric pressure. You are going same height H, so it is this plus H rho G. So this plus H rho G, this plus H rho G, and therefore the pressure becomes same here, here, and here. So in one horizontal level, the pressure is same everywhere. No paradox.
So means volume 3 is high, volume 1 is in the question V1 is
हाँ आप देखो ना ये बेस एरिया आपका सेम है मान लो ये बेस एरिया आपका सेम है और ये ग्लास ऐसा सीधा नहीं होगा कि ऐसे होता और उतने ही हाइट तक भरा होता तो कितना सारा पानी आया होता और वो ऐसा कोनिकल फ्लास्क की तरह चोंच की तरह यहाँ पे बना होता एरिया इतना ही है तो बाकी की जगह में तो पानी नहीं है ना अभी इतनी दूर में पानी है से इट इज 50 ml now if I this glass is converted मतलब I take a different glass of this same area but now it is spreading out and up to same height I have to fill so I am putting more water and if it is like your conical flask of the same height so I am putting less water. Okay, so the question is that the weight of this is less mg because you have less mass. This weight is more here and the weight is largest here and everything is in equilibrium. So here I will say that this upward force is equal to downward force. So this P into A is equal to W1. Now paradox is coming. The same principle applied here. The downward force is W2. The upward force is PA. So and it is in equilibrium. So PA is equal to this was W1. This is W2. And here this P times A upward force. This is the upward force by the bottom. And then gravity B W3. So it is W3. Left hand side is same and right hand sides are different and I am putting equality sign on all
so
the
why
three
they are
cases.
not
That's the paradox.
नहीं एरिया तो सेम
हमने बर्तन लिया है समान एरिया का और उसकी शेप अलग अलग है एक ऐसे फैली हुई है एक ऐसे सीधा है और एक ऐसे वो तो मैं ले सकता हूँ there are three independent vessels. I can always take equal area and put the shape.
वॉल्यूम के लिए A into
So that's the paradox.
height.
सर बट व्हाई देन who
अगर A चेंज कर
ये
दें
सरफेस डिफरेंट है तो
L को भी
सरफेस
change
का
होना
नॉर्मल रिएक्शन जो है वो बैलेंस कर देता है
नहीं मैथमेटिकली सर हाउ आई विल शो आफ्टर दिस स्टेप
नहीं मैथमेटिक्स का जरूरत नहीं आप पहले फिजिकली भी बता सकते हो वो बता रही हूँ मैंने See when you say that upward force is equal to downward force for equilibrium you should look at all the forces which are acting on the system. We have not done that. Earth is pulling down, we have taken care. Bottom is pushing up, we have taken care of. But then this bottom surface of the vessel, we considered that since water is in contact, this bottom surface is pushing it up. But water is also in contact with this
Side walls.
यस
Okay.
and these side walls are also exerting force on the water.
So overall effect.
So if you consider this one, this wall is exerting a force in this direction. This wall is exerting a force in this direction. So there is a vertical component out there. And then the weight is there downward. So this W is not this W1 is not equal to PA. This W1 this is the gravity, and then the components of these in vertical direction, they are also to be added with the gravity.
Yes.
These are also downward components. So plus that component of the normal.
Okay.
And what happens here? What happens here? Here also there are side walls. No vertical component. The forces are very much there, but no vertical components. And horizontal components also cancel out. From here the force is like this. 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 Just like in our this water. Here the force is like this. This normal contact force. From here it is like this. The glass is pushing the water. So this way, this way, this way, this way. The resultant is this in horizontal direction as well as in vertical direction. Okay? And in this case,
they're subtracting from the weight.
so from gravity you have to subtract that.
Yes.
And when you do that, then everything is fall in line. All equations are equally correct.
Very nice.
नहीं ऐसा
हाँ, पर वहाँ से आवाज आ रही है कहीं।
Okay. The questions में दिया है. Right. हाँ. एक बार. इनका लीजिए. हाँ.
ये किसका है?
सर का तो नहीं है, सर का है ये तो।
मुझे लगा आवाज आई तो आपकी आ रही है। दूसरी सर्कल।
हमारा इंडक्टर वोल्टेज का सोर्स बन जाता है। मतलब वो वोल्टेज नहीं खाता। मतलब हाँ उसमें एक अपोजिट ईएमएफ जनरेट होता है। उससे नया बन गया।
See, LDI in the inductor, when your current is varying, there is an inductor and the current is varying. Yes, it produces an EMF. There is a source of EMF. Voltage में बात नहीं करना चाहिए, because ये जो EMF generator induced EMF generate हो रहा है, it is because of the changing magnetic field. When you have inductor and there is a current, what is inductor? Basically a coil, or model it as a coil, right? So when you have current in a coil or a solenoid, there is a magnetic field. When the current changes, this magnetic field changes. And this changing magnetic field creates electric field. That gives me E dot PL. That appears as EMF. But corresponding to this electric field, I should not technically, मेरा काम चलने के लिए अगर वो is fine, मुझे पता है कि इससे मेरा रिजल्ट मिल जाएगा, तो I will use it. But technically, purest view, this electric field is a non-conservative field. EMF is generated because of this induced electric field, and so we should not talk in terms of potential difference corresponding to this inductor. वो इंडक्टर के क्रॉस माइनस एल डी आई डी टी का एक पोटेंशियल डिफरेंस पैदा हो गया है. दिस इज विल बी क्रिटिसाइज्ड बाय द प्यूरिस्ट. नहीं ऐसा मत बोलो, ऐसा मत. ओके, दिस एल डी आई डी टी माइनस एल डी आई डी टी इज EMF, not the potential difference. There is a difference between EMF and potential difference. So in the equation it's fine that when you put a battery and a current, EMF is E, then you do that current is EMF divided by R. Okay? And that EMF happens to be equal to V2 minus V1. But if you say that it is EMF E divided by R, what is the problem? So minus L di dt divided by R, fine, that is also an EMF. You have other EMF sources, so this is also source. So that I into R, the current there, is EMF, total EMF. It may come from your AC source, or it may come from changing this flux in the inductor. Everything taken together, then you write your own law. Equation ठीक है. हाँ, वो तो आप देख लो कि किधर कौन ड्राइव कर रहा है, जो करंट को जो बदल रहा है वो किधर ड्राइव कर रहा है, ये किधर ड्राइव कर रहा है. नॉर्मली ड्राइव्स इन द अपोजिट डायरेक्शन, तो माइनस प्लस वो आप देख लो, ईएमएफ के साथ उसको जोड़ना है. बट द बेसिक इज दैट if you go by this view, it's not a potential difference. In fact, on this aspect, Walter Levin is very, very aggressive. Walter is very, very aggressive, and since he is blunt in the language, all physicists do it wrongly and all teachers do it wrongly. वगैरह वगैरह बहुत हल्ला गुल्ला मचाते हैं उसके ऊपर. But equation में कोई फर्क नहीं पड़ता. इक्वेशन में कोई फर्क नहीं. ओके.
सवालों के साथ ही 2025 बिताया जाए, जवाब मिल जाएगी कभी कभी, लेकिन उनकी खोज जारी रहे. जवाब मिलने की खोज खुद भी हम सोचते रहे, सवाल अगर उठते रहे हमारे मन में. तो with that we have to wind up today's session, but I have these sheets and there are other sheets also, so when you're going for your dinner, then you can please pick up all these sheets or who have not taken. I believe that homework तो शायद बहुत ही कम लोगों ने दिया है. अगर काम हो गया है तो वो return all your sheets. I thought I would bring it now. We'll return it tomorrow. If I forget by any chance, then please ask for it.
We will
and
take
take
it.
it with you. Okay?
आज ही नहीं.
I think here. Homework anyone?
Homework. ले लिया मैंने. हाँ.
We have given out two. There are two more. So please carry that with you. We did not finish today the tutorial except for a few.
हाँ जी, स्वेटर भी है. No problem. चलो मैं भी ऊपर बैठी हूँ. नहीं हो रहा है अभी.
Now you will ask what are all the forces acting on the water. You will say there is downward acting weight plus or one half for the point. Then you have the upward force F, that is the pressure in the area. And the normal force is acting from all sides. So imagine that in this glass, but this is like curved glass. So at this point force is this, at this point it's like this, at this point it's like. So you have basically an arrow that is going like this. If you resolve these arrows, you will find that all of them are correct, which means that net downward force of W1 plus the normal perpendicular component. This is equal to नॉर्मल का परपेंडिकुलर कंपोनेंट यहाँ पे डाउनवर्ड है ना, तो टोटल डाउनवर्ड करेक्ट. So that means net downward force becomes W1 plus this total downward component of the normal force is equal to F. And in this case, again you will say you are filled it up with again this is water is your system. So again you will say W3 is the downward force. F is equal to PA is the upward pushing force from the surface at the bottom. But now the normal thing perpendicular to this side. It's like this. Again, if you resolve this, now normal and upward comes.
For the very first year, 2024 was the
Which means now you will have to say
अपने आप को इससे पहले 2-3 बार इसके बाद मैंने 6 बार पढ़ी।
अब यहाँ पर
Like my culture is almost Punjab because found me perpendicular में मैं got married at Chandigarh तो वहाँ पे साड़ी का कोई मतलब नहीं है। हाँ वो साड़ी पहना के लगती है। अच्छा हिमाचल में साड़ी is not in trend। हिमाचल का अपना कल्चर है तो people पहनते
डाउनवर्ड डायरेक्शन में ना या कल्चर में कुछ कर रहा है.
हरियाणा का कल्चर है साड़ी तो पंजाब का
Press the walls down. Push the liquid down.
हाँ पंजाब में सलवार
वो लिक्विड को
मुझे
नीचे दबा रहा
आज
है.
जो शॉपिंग करनी है मैं आपको स्पेसिफिक बताता हूँ।
है ना? तो मतलब मेरे तो उसका मास्क डाल दिया लिक्विड का. इतना जो इतने कंटेनर में जो लिक्विड भरा हुआ था
जो
ऐसे
कर
करने के बाद
एकदम
लिक्विड
जल्दी
तो कम हो
टाइप
गया.
के थे,
मतलब ये वाला जो बेसिकली पार्ट है यहाँ का वो कम कर दिया मास्क उसका. और मुझे बट वी आर सेइंग नाउ इवन दो हमने वो वहाँ से लिक्विड निकाल दिया वहाँ से हमने सरफेस को तो दबा तो दिया लिक्विड को अंदर की तरफ तो वो नीचे भारी नहीं तो वापस वो बैलेंस करेंगे. वही उल्टा अगर हमने उसको बढ़ा दिया मतलब
ज्वेलरी वाले
हमने
देखते
एक्स्ट्रा
हैं
मास डाल दिया और भारी हो गया तो और भारी हो गया तो उसको कौन बैलेंस करेगा. तो ये बेसिकली इसकी जो कंटेनर
दीक्षा से
एक्चुअली
हाँ मेरा स्कूल से ना जस्ट निकलते ही मेट्रो स्टेशन के बगल
नहीं ले जाओ नहीं
आपने वो पूछा मुझे बहुत बड़ा अच्छा लगा.
क्यों सारे कंपटीशन है क्या कह रहे हो कितनी देर दिखा रहे हैं अच्छा ये बेस 7
वो बड़ा अच्छा है. सर ने जो थोड़े वर्ड्स बोला ना
ये हाँ ये बहुत ये मुझे मैंने इसको
पर आपका क्वेश्चन मुझे समझ नहीं आया क्योंकि मैं सुन तो रही थी पर ये मुझे समझ नहीं आया.
आपका क्वेश्चन तो मतलब अभी तक मैं वो उसमें सैटिस्फाइड ही नहीं.
हाँ क्या लिफ्ट में वो
नहीं लिफ्ट
ट्यूब वाला फिर हम कुछ कह नहीं सकते थे ना मैंने ट्यूब वाला हो गई थी
ऑर्गन टाइप
मैंने पूछा कई बार कहीं ना कोई टॉपिक ऐसा भी होता है ना तो हमको लगता है कि हाँ कंपनी का शुड आई आस्क कुछ तो है उसमें ना.
हाँ वही समझ में नहीं आ रहा है क्या है. एंड आई जस्ट
तो क्वेश्चन है कि क्या क्वेश्चन है आपका
कौन से वाला लिफ्ट वाला
और तो वही पूछा है
ऑर्गन पाइप वाला तो ये था कि ऑर्गन पाइप से वेव निकली यहाँ का रिफ्लेक्ट कैसे हो गया.
कैसे आ रहा है वापस आने में काफी टाइम लगेगा.
अच्छा एक बताओ
आगे आगे भी चल सकती थी ना ऐसी बाउंड्री ने ऐसे क्या कर दिया
इसलिए ना मोमेंट ऑफ इनर्शिया 1/4
वो वाला होता है वो दोनों साइड से ओपन होता है।
होमवर्क मुझे भी नहीं मिला
मुझे भी होमवर्क
ये लो हम करेंगे आज व्हाट्सएप पे कैसे
सेक्शन है जो मार्क करने
कहाँ डांट मार